Hey guys, welcome to the Science Fair workshop. So we're going to give everyone a couple of minutes to start coming in, and then we'll probably get started a couple minutes after 5:30. Today we'll be covering research plans and how to properly conduct research for your projects, since that will be one of the first assignments that you guys will do in school for Science Fair. So, and then we'll play a Kahoot about it, and then we'll be able to talk to you about your projects.
Yeah, going off what Caitlin said, this time is gonna all have a lot of focus on what projects you'll be getting into, right? We're gonna be splitting up into groups at the end, and so you guys can really get into your projects, and us mentors will be there helping you guys out, really flesh out your ideas and make them as best as possible. So, yeah, just a few more minutes.
Hello? Okay. Nobody's talking.
Hi, we're just waiting a couple minutes for everyone to start joining, and then we'll get started with our workshop.
Okay.
Yeah.
Okay. It is 5:33 right now, which means I think it is about time we get. I believe it is about
Anthony,
time we get started. Is everyone cool with that? Or are my mentors down?
Yeah, I'm good with that.
Yeah,
Okay.
that sounds good.
Okay. Yeah.
ready
So
when you are.
once again, thank you everyone for coming here. We really appreciate it, and we're gonna get started with the lesson. Obviously, today. Okay. First off, I want everyone to click on my name is going to be at the top of Science Fair General Voice, and it's going to say live. I want everyone to click that so they can be watching my screen to see what's happening right now. Okay. Cool. So today, we're going to be working on dreaded research papers. That's right, okay? This is an incredibly important process and part of the science fair process and just science and research in general. So we want you guys to know as much as you can about this so you guys can succeed as well. This is workshop 7. So today, what mainly we're going to do is we're just going to recap on some of the useful things, research methods that you can do, tips for writing good, solid research plans that comply and follow all of the APA format rules, and just making sure you guys have down all of the exact details, because that's incredibly important with these science fair lectures. Because when you're in the science community and you're reading all these research papers, everything has to be pretty much the same so that you can understand as a reader what's happening. And we want this process to be held over as much as possible. So who would like to speak first?
Yes, so a research plan is basically going to be a document written to propose a project idea. So it's basically showing your purpose and like application, why your work is going to be important to the scientific community, if you will, and basically why your judges should listen to your project and value it. Then you're going to provide valuable background information that gives the scientific knowledge behind your topic, and then procedure of the project. So this is going to be your step-by-step process of the steps you will take to get accurate results to draw conclusions from.
Okay, would anyone else like to speak?
So the basic parts of a research plan are background research. So this is you write the background research and all of the background information for your project. And then the second part is the question. So if you're going to be doing an experiment, this would be your hypothesis. So this is like what you're trying to solve. And if you were going to be doing an engineering project, then that would be your problem. So like the problem you're trying to solve. And then the third part is methods, which is basically your procedures and the materials that you're going to need for a project. And then the fourth part of the research plan is your bibliography. So that's like all of the research papers that you've read and all of the works that you've cited in your research plan.
Okay, so the first part of a research plan is the background research, okay? So in this, we want you guys to research, obviously, and write up in depth about the science ideas and theories and everything that goes into your project, okay? And as Caitlin was mentioning earlier, it has to explain why is this important? The why, right? That's extremely important for all of this because people have to care about what you're doing. Additionally, the research should be around 2 to 5 pages and make sure your sources are in APA format. You can generally just look that up in Google or use like APA citation machines.
Mm-hmm.
Okay, who would like to go?
So this basically covers some of the most basic types of citations that basically as you write your research, a lot of times your teachers will require you to cite the sources that you're using throughout so that you can give credit to the author. So you'll notice that we have different formatting based on the way you were to the type of source used and the way you incorporate it into the text.
Yeah. Going off that, there's a bunch of different ways, right? You can have just the author, and these are different types of basically embedding it into your quotes, right? So you can just you can have all of these different types, right? Their name, what they did, another study by X, all of these types. And you can look at into them more in the future. Okay, so who else would like to speak?
I can speak. The next part is the question. So this is the second part of your research plan, and it's either a problem or a hypothesis, and that depends on what type of project your project is. So if your project is going to be an experiment, then you would have a hypothesis, and the hypothesis is basically like an educated guess, so an if-then statement about your project and what you think is going to happen in the experiment. And your goal is the goal of your engineering experiment. So for example, how you would want to improve a certain product or something like that. And everything must relate to the problem.
Mm-hmm. One thing I would say is it's really important that what really will take your project to the next level if you base it off of a problem you have identified or an issue it could help solve. That's going to really grab your judge's attention and give you a purpose for your studies.
Okay, can we get another mentor to speak this time?
All right. So methods and procedures pretty straightforward. It can be broken up into three main parts. So the safety materials and the actual procedure. For safety is basically just all the safety precautions needed for the experiment. So like proper clothing and proper like grounds for the experiment. For the materials, it's just a list of materials needed for the experiment, and the procedure are just the steps taken to complete the experiment.
And the last part is the bibliography, and this goes at the end of your research plan, and this cites all the sources that you use for your research. So you want to use the APA format, and you want to use every single source and cite it. And yeah.
Mm-hmm.
And when citing sources, you want to make sure all your sources are credible. So using .edu, .org, and you want to include at least 1 or 2 research papers, or yeah.
Okay, yeah. Going off what I believe that's what was saying. I know CISD actually has a lot of databases with a lot of data. I believe it's the Gale database, right?
Yes,
Can
that
I
is
get a check
one.
on that? Yeah, so that's one of the many databases that CISD offers, and those are all credible sources. You can also go onto places like Google Scholar or like a bunch of different scientific journals, PubMed, etc., that you can all of them have great research papers that you can find great ways to really cite your paper and understand the subject that you'll be working on. Okay, so
this is basically an acronym which is going to help you check to see if the sources that you are using are reliable. When you're presenting, you will often have to give a bit of background information about your project so your judge can understand your topic. And so you want to make sure you're giving them accurate information. If not, these people know your topic, so it might be a little bit embarrassing. So this is a little acronym you can use. So we have currency, so the timeliness of the information. So preferably within the last 5 to 10 years at the very least. If you're using say a book from 1950s about biology and they don't even mention DNA, that's a pretty good sign that the source you're using is not the most reliable, up-to-date information. Then there's also relevance, so the importance of the information for your needs. So how strongly does this connect to your topic, or is it mainly focused on something else? It's best to choose websites and journals that give as much information on your topic as possible to save you time in the process. So then there's authority, which goes back to the different like web browser endings we were discussing. So that's basically making sure that you have a trustworthy site and the author is a reliable source and you can trust this information. And then we have accuracy, which is fairly similar. So that's looking for sources of bias. So say you're doing like an economical project or something like along the lines of that. There's lots of factors of opinion in it. You want to eliminate anything like that. And then purpose. So why does this information exist? Like, is it heavily sponsored and that's why? Or is it objective to something? You want to make sure that just eliminate any of those factors.
Awesome. So, does anyone have any questions about the subject? If you do, please unmute yourself, because obviously asking questions is the best way to really understand a subject fully. So we obviously welcome that kind of thing.
Yeah. We know this isn't the most exciting topic ever, but it is a really important skill that you'll use all throughout high school and college. So we wanted to make sure you guys fully understand it, especially since different people are using different platforms of learning. You may not get the same input from your teachers this year. So please feel free to ask any questions.
Okay, well, if no one does have any questions, I believe we can start on the what is it called again? I forgot.
The
The
Kahoot?
Kahoot. Oh my
Kahoot.
goodness, the Kahoot.
Okay.
Okay. Awesome. So you have the link, Caitlin. Are you willing to share it? I mean,
Yeah, of
screen
course.
share?
Yo, Nathan, what's the
Or
Kahoot over tonight?
would you like me to switch my screen share?
Yeah.
Okay.
What's the Kahoot over today?
We're just doing over. It's gonna be over some research topics, and then after that, we're gonna really get into just like helping everyone out with their projects. If you're willing to help as well, then
Yeah,
we'll
definitely.
get to you
I was
when the
thinking, like,
time.
if anyone doesn't want to do the Kahoot, that's fine. Like, I'm free to go to a different channel and talk about, I guess, independent projects.
For what it's worth, we are doing that immediately after this.
Yeah,
Right?
this is
So
a
it's only
fairly
just a
short
minute.
Kahoot game.
Okay, yeah. Okay, cool.
Okay, so you'll see that the game pin is 13864444. I'm going to go and put that in the announcements channel so you guys are able to see that.
Wait,
Oh,
what is it again?
sorry, it's showing the wrong. Okay. There we go. Okay. Everyone should be able to see that now.
And Caitlin said she put it in the chat, so if you guys
Kind of.
don't remember, just
Okay, so if you go under signs for announcements, you should be able to. And then
And for those of you,
sorry.
yeah, for those of you who haven't already, click Caitlin's name at the very top and it'll take you to the Kahoot, or at least the live stream of the Kahoot, because we only have 17 viewers right now.
And in the background, if you're curious about what's playing, this is a video from our regional fair last year, the Science and Engineering Fair of Houston. So hopefully a lot of you guys will be able to make it. It will be hosted online this year, but it's still really great to compete your project against better projects so you can be inspired and see what other people have come up with.
Will Lose is back.
Yes, they were with us in the summer.
Totally not me. Like, not me.
Okay, how close are we to getting everyone?
We have 14 members right now.
Okay.
Is there anyone that wants to join and is unable to? Okay, and if you were unable to join, if you joined on a phone or something like that, it's okay. Just like you can feel free to like sit along and just watch the questions so you can still get an understanding of the material. And then this will be a very quick game, and then we're gonna go straight into talking to you guys about your projects and more. Okay, I'm gonna start. Okay, so just to clarify, we want you guys to be writing your research paper not because you have to, but to help gain a thorough understanding of your topic, since that is really important when answering questions coming from judges, and just getting to know your topic more because we want you guys to pick something that you're interested in. This will also be, since this is your research, you'll also be forming your engineering goals and hypothesis based off of this, so it's important that those are based off of facts. Next question. Okay, so nearly everyone got that one. Just to clarify, all citations will be done in APA format. There's going to be music now, if that makes it more interesting.
I do not believe we can hear the music, but that's okay. We can have some funny commentary over it, guys. So, how's
Oh,
everyone
we
saying?
can't. Okay.
It's alright, don't worry about
You
it.
know what?
Okay.
Okay. We'll read over the questions. How about that?
Yeah.
Mhm. Yes,
like-
so
The presenter voice. 'Cause that's always fun.
okay. Yeah, we only have one person that answered it's on the rubric, so good job,
Has-
everyone over here.
Did you hear, like, kind of discuss the research plan yet? Have you guys gotten there at this point?
Don't
The
worry,
research plan?
Like, has any teachers discussed it yet?
Yeah, okay. This is a question going out to the students.
Mhm.
Yeah.
How have you guys been like getting taught all of this research related stuff? How because
all
obviously
is she right now my assignment right now I still have to do this is I have to submit my final question, and I don't think I'm gonna research until next semester.
Hang on, next semester.
Next semester, I think that'll most likely be your next assignment. So right now, if you're submitting your questions and hypothesis, we'll talk to you more about that like once we go into the smaller group. So it'll be more one-on-one.
Alright, got it.
Okay, so I think, judging by the comments, it seems as though it just depends on the school.
Mm-hmm.
Maybe the research plan will start next quarter, if that was what it is. So yeah, let's keep going on with the Kahoot so we can get to everyone's projects.
Yes.
So, what are some of the important parts of a procedure, okay? Hypothesis, bibliography, question results, materials and steps, or conclusion and hypothesis. Please choose your best answer and put it in quickly so we can get to you guys.
Okay, so this was specifically the procedure, not the whole research plan, so that is purely just your materials and steps. So
Okay,
which
so
of these
what
do
do
you... Yeah,
go.
sorry.
There you go.
Okay, so which do you not want? We kind of discussed this. Yeah, so you definitely do not want biased statements because that means the information they are giving out will be leaned to one side and may not be fully reliable, whereas you want to base everything you do in your project off of facts.
He is still in the B.
Which of these is a hypothesis? So, is it always a correct statement, an educated prediction, a fact that the researcher found, or a question that they had? So yeah,
Yeah.
I think this was definitely in the curriculum at school, I'll bet, right?
Mm-hmm.
Hypothesis is an educated prediction on what you think is going to happen.
Yeah. Your question is separate. So your question is asking, whereas your hypothesis is predicting the answer. Okay.
Can anyone capture me?
Yeah.
So, will my original hypothesis always be correct?
False. And it is okay if your hypothesis you actually find to be incorrect, because then you're able to explain why you think it is that way and talk further into your background research and what you did throughout your procedures. So it is absolutely fine if your hypothesis is incorrect.
So, why do we use the scientific method, okay? Do we use it to help them determine a good conclusions, teacher said so, a process that most scientists follow, or to organize experiments?
Yay! Okay, no one chose my teacher said so. So everything was correct except that one.
Ooh,
Wow.
uh-oh. A nooch. So, which of these is the purpose of a procedure? Just to predict something that could happen, some loose guidelines for the experiment, an extremely detailed set of steps, or just conclude, oh, okay, never mind.
Okay, yeah, so it is a detailed set of steps to predict is your hypothesis. Loose guidelines, you don't want it to be really loosely. You want it to be exactly what you follow. And it is okay to revise this after you finish your experiment because things may go wrong that you weren't originally anticipating. And that's okay, that's part of the process.
Yeah, especially in engineering. You
Yes,
change everything.
exactly, in engineering.
Okay.
This goes with what I just said. Of course, you can change it if needed. Yeah, so if something happens you weren't expecting, it is okay to adjust it to make sure everything is
There's,
reliable. Mhm.
there's one rebel.
Yeah. Okay, we're almost done now, and then we can talk to each of you. So keep in mind, procedure is a set of steps you follow.
Do you think we should try like speed rounds for the last of these?
Yeah, I'll do that.
Yeah, 5 seconds.
Yeah. Hopefully
Okay.
5
3
doesn't
seconds.
get you guys too bad.
Only the strong survive.
Okay, yeah.
Okay. True or false? You should enjoy learning about the topic you were researching. This goes with our whole goal at Teach to Learn.
Okay. 5, 4.
3, 2, 1. Okay. True. Yes, you should. Thankfully,
Hey,
everyone chose
everybody got
that.
it right.
Yeah.
Yeah, we'd be a little concerned if you didn't.
Yeah, you should always be passionate about project you do.
Mhm. What does an
That
in-text
makes sense.
citation look like? So this goes with what we showed you.
10, 9, 8, 7. Dope.
So there should be some form of parentheses throughout it. You can't really necessarily, whether that's just around the year or around both, you never really just leave it blank like that. Okay, final question before we split up into groups. So it is important to keep track of all the sources you use to research your project.
Okay, 3, 2,
Okay.
1. Yeah.
Great.
Okay.
So it is, because you will be forming your bibliography and you do not want any form of plagiarism throughout your project. That would not be good. So now I'm going to end my screen share since, oh wait, we should see who won.
Wait. Okay. Who gets fake internet points?
So
Do we have permission to give roles anymore?
I'm not sure.
Yes. I mean, we're admins.
Yeah.
Yeah.
Okay. Yeah. Congratulations
Okay.
to everyone who did well, because yeah, obviously you probably learned a good bit about research plans. But now we're kind of gonna get into like the basis of what this is all about. And so, if everyone can please look under science fair discussion, we have the groups that you guys are going to be going into. So hopefully most of you guys probably, since I've seen that everyone's turned in most of their questions already, we have each of the groups, science fair groups that you should go into, okay? So we need everyone to go into one of these 5 groups. Hopefully everyone fits into one of these categories.
Yeah, and
So
if you're
please
not
go there,
sure,
and we'll be there.
yeah, and if you're not quite sure yet, feel free to just join a random group and we will be able to help you out. I'm going to read them aloud for you. So group 1 will be computer science, group 2 engineering, group 3 behavioral and social, group 4 will be life science, and group 5 will be physical science.
And yeah, so engineering is obviously like electrical, civil, mechanical. Physical science would be like chemistry or physics. And
math as well will also be classed as physical science projects. And
so hopefully
aerospace
everyone
can really
has a
be the
place
one.
they can go.
Here, I'll fill when I see where all the mentors distribute to. So
Okay, cool.
Yeah,
looks
everyone
like
please.
Alex, you're muted right now. Okay.
Ew, did I not get a high? Come on, man.
Okay.
Okay. Do we have any? Okay, Catherine in life science. Great. So what?
Yeah.
Okay, well, there's
So
two. Okay, there's two.
Hopefully everyone
okay.
gets
So you guys joined this group because you're interested in doing an engineering project. So Nathan, Ben, and
Yeah.
I will all be able to help you out and talk to you more one-on-one to kind of replicate that in-person experience as closely as possible. So if everyone wants to turn on their cameras, that would be really appreciated and a lot more helpful.
Yeah.
Yeah, and we're
Okay,
students
well,
just like you are, guys. We understand the whole online school kind of thing.
I don't really want to turn on my camera because it's like iffy. Like I need to like restart my computer. It's not working right now. But like, can I just turn on my mic?
Yeah, that's fine. If
yeah,
it's
I
a
mean,
technical problem, then.
Okay.
Hey, good to see you. Okay. Ben, are you able to right now?
My camera doesn't work, so
Okay, that's fine.
it's all good.
So, Inu, am I saying that correctly? Just to clarify.
It's Inu.
Inu, okay. Do you want to start with telling us about what your project, what you're interested in, and what you're planning, if you are already for a project?
I'm interested in engineering, like electrical engineering, I guess.
Mm-hmm.
And my project idea was trying to create a light system that consumes less energy by adapting to its conditions. Like if there's some ambient light in the room, then it would adjust the brightness of the room. And if there's people in the room, then it would also turn on and off the light.
Okay, that's great. I remember you from last year, actually. We were sit across each other in Houston.
Yeah.
Yeah, okay, you remember? Cool. So, yeah, I know you did well last year. So, yeah, that sounds like a really cool idea. It sounds like you already have a really solid application for that as well, which is great since that's really applicable to real world situations. Do you currently have a plan on how you're going to?
I'm thinking of just starting by just analyzing like the time that light is left open in my house and doing like small experiments just to find some data and then using that data to program a system to adjust to those data.
Okay. Yeah, that's great. So is that going to involve computer science elements as well as?
Yeah, I think I'm gonna use like a Raspberry Pi and
Yeah.
program the Raspberry Pi to adjust to those conditions.
Yeah. Okay.
Okay, I've done some stuff with Raspberry Pi.
Mhm.
I mean, no, I haven't actually. Do you know how to use Raspberry Pi because it is its own computer, and that is somewhat difficult.
I started a little bit on using it, but yeah, I'm getting to know how to use it a little bit more and more.
Okay. Okay, good.
Yeah,
I
that's
mean,
great.
personally, I'd recommend Arduino because it's a little bit easier, and you can probably put the data onto like an SD card or something. But obviously, if you prefer Raspberry Pi, then go with it. But
Yeah.
it is its own computer, and so it has its own operating system and everything. So good luck on that.
Yeah, and I understand that company is also like a Broadcom sponsor, so it's definitely got a good it's a good program. So it sounds like you have a pretty good plan so far, and you know where kind of direction you want to go with it. So, Rohit, am I saying that one correctly too?
Yeah, that's correct.
That is correct. Okay. Do you want to go ahead and share with us what you have?
Yeah. So for my project, I created a convolutional neural network to detect respiratory conditions, and I integrated it. I loaded the model with like TensorFlow Lite in an H5 file, and I integrated it into a web application.
Okay, that's really good. Are you in 8th grade or what school do you go to?
I got a not.
Okay. Yeah.
Wait, why are you not in computer science, by the way?
Oh, because it's like an engineering. Well, okay, because it's a machine learning project, and I kind of feel like computer science and machine learning. You know, you think of like two different things. Like computer science is more like programming systems, and machine learning is its own kind of thing. So,
Yeah, I think
um,
in the
yeah,
category of robotics and intelligent machines, they have machine
yeah,
learning projects in there, so that's definitely would be a
Yeah, I
category
mean,
that would work for you.
yeah.
I'd recommend just going to computer science. I know both Aditya and Ashton do have experience in that kind of stuff. So, I mean, I'd recommend
I will,
checking out what they have to
yeah,
offer.
I will say this:
Like,
computer science is a really big, really competitive category, whereas robotics and intelligent machines maybe had about like 6, 7 projects in it last year at Houston. So I'm not sure exactly what your goals are throughout this process, but I definitely think you could do really well in both categories, definitely, if you were to able to execute that correctly. But like
yeah.
statistically speaking, your odds would be higher of winning in robotics and intelligent machines as long as your project fits like the brief.
Yeah, robotics and intelligent machines in the category description as well. Like it's a machine learning
Yeah.
category. It's in the description.
Mhm.
And I know I contacted Kabir.
I was
And,
gonna say you reminded me of
yeah.
Kabir. You said that.
I contacted him, and I know that he did projects, you know, concerning machine learning, integrating them into applications as models.
Yeah.
And he went into robotics and intelligent machines. So I feel like that's the better category for me.
Yeah,
Okay, yeah.
he beat me. Yeah,
Yeah.
it's good stuff. By the way,
I have a question.
Oh yeah.
I was like wondering what category I should go into for my project. I didn't know if I should go into energy and transportation or engineering, electrical, mechanical, civil.
My advice to you is engineering, mechanical, civil, and electrical. I said that out of order, but basically because it sounds like you're trying to develop something more and it's an engineering category, whereas energy and transportation is a physical science category.
Okay.
So, and that's more for experimental. It sounded like you were trying to develop something. However, you are also testing it, so I could see how it would work with both. I think that's really just up to you for that one.
Okay.
I mean, yeah, I'd suggest electrical. It's probably best
Okay,
there.
yeah.
Okay.
That's where I'm
I don't-
Thank you.
Mhm.
I mean, for both of you, I would recommend going ahead and checking out Science Fair Group 1, just in case, because you guys both do have significant computer science aspects. But, and obviously you can stick around, but other than that, you guys don't have to be here forever. So
Yeah.
if you don't have any other questions or don't want to see what the other mentors have to offer, then you guys can go.
Yeah. And if
Oh,
you have
wait,
any
actually-
concerns about your projects, feel free to like share those with us and we'll be able to help you best navigate around that and help you out with any problems you may encounter because both of you have quite ambitious projects, which is great. That's what we want to see. And so feel free to message us at any time if something were to come up that doesn't really work out the way you need it to, or if you just need a bit of further advice, we'll be able to help you on that.
For thermometer man, I will say I do have I don't know your name, but I will say I do have some experience kind of trying to integrate more like computer science ideas with more like electrical civil kind of that kind of area. I know that one year in sophomore year, actually, there was a kid that did something along the lines of what you're doing, essentially like integrating some type of computer algorithm to make homes more energy efficient. And he got a grand award at Dallas. So his project was incredibly good. But I mean, yeah, so I did my stuff with an Arduino, obviously, but um, so I can't really help you in terms of like a Raspberry Pi or anything, but I do have essentially basic experience in some like circuit stuff and all of that. So
Nathan,
if
you
you guys
started
have,
a
yeah,
stream. I'm not sure if that was
that
an
was
accident.
purposeful. It was.
Okay,
But
yeah.
one of the big things about Teach to Learn, right, is that we're just basically mentors for you guys and we're trying to help you guys. So if you guys have any questions, please feel free to reach out to any of us on like Discord or I guess the Remind thing as well. But
Yeah, you can message
yeah,
us back on that too. And both of you, I understand, have the resources to do these projects at home because that will be a lot harder to access given our time. Yeah,
Yeah.
because you got your computer software. I understand that yours is very computer science based too. So yeah,
I mean, yeah, for Rohit, I'd recommend going actually to the science fair group. Like Ashton's pretty into that.
Yeah, yeah. Yeah, yeah.
Okay.
All right.
Good stuff.
Thank you.
Thank you guys. Oh, new people.
hi.
Hey yo, ma. Okay. So someone new has joined. So what is your project? Can you unmute yourself and tell us? No. Okay.
Guess not to know.
Or I'm gonna stop streaming.
Yeah, those are both really good projects.
Yeah.
I was
They
stood
are.
across from at science fair last year. He
Oh
came
really?
second.
Oh wait, was he the kid that did the bicycle?
Yeah, that was
The
him.
bicycle wheel?
He was the bicycle one. He did a partner project too
Mm.
last year. It was really good. Honestly, it came second at Houston, but it only came fourth at district. Which, no idea
I
how
mean,
that happened.
it's probably because they're parents and they're like, oh, that kid didn't do it, or something along those lines.
I guess.
I mean, yeah, what else would it?
I mean,
Like,
I've had people ask me what my parents do. But, yeah. I guess that's like a compliment in kind of a weird way.
I mean, it's definitely a compliment, but it's like, it's kind of a, they think it's too good to be true kind of compliment.
Yeah. I think as long as you explain your concepts correctly and everything, and you are honest about what help you did get, then it's not really a problem.
I remember, I think someone asked one girl that, turns out her dad was a physicist.
Oh.
So,
Yeah, that's not the
you
kind of
know,
answer you want to give after a physics and astronomy presentation.
but her
Yeah.
project was still really good. Oh well, I'm probably gonna join another one of the groups.
Yeah, fair enough.
Actually, no one's in physical science.
Is
I feel
that group
there's no like.
group 5? Oh, there's no students.
I'll go in like 3 minutes and see if anyone actually.
Hi. Oh, he's gone. Hello. Sorry, you don't have your name listed, but feel free to unmute yourself. And oh, he's gone again.
Should we stay or should we go into different groups? And
I'm thinking I'm gonna join a different group. However, I'm not sure which one because I only have
Okay.
experience in engineering and physical. Everyone's left engineering now, and no one joined physical, so
yeah.
I'm probably gonna sit in on the life science one because they have a lot of students in there.
All right. Should I just sit in engineering in case someone joins, or should I just?
Yeah, we can actually wait. I mean, I can't help with computer science. Ashton's dealing with that. Then Alex is doing what's group number 3? Behavioral and social. I know nothing about that. Then group 4 is pretty big. But then it's now more mentors than students, so. I'm just gonna.
All right, cool. I see. So do you have a hypothesis yet?
Not yet.
Okay, so continuing to do research, like background research, will help you get to to your like predicted, like your educated guess, like which is your hypothesis.
Okay.
Wait, by the way, I noticed no one actually joined physical science. Is anyone here actually in physical science and they're just
so we have one
Oh,
that's
life
like
science.
shampoo, but that's life sciences because it's because the way it's integrated into the health and
That's
medicine.
medicine and health. Yeah.
Okay, yeah. Never mind.
So I think we're all good in terms of which categories, because I'm pretty sure everybody here is in life sciences.
Okay, cool.
And he's gone. The majestic Nathan.
So does anyone have any questions about their science fair project or like comments about it?
Yeah, if you guys want any like advice or tips, then we feel free to give it to you.
Question.
Yeah, go ahead.
So my project's probably gonna take a little time because it takes around at least a month to compost, like decompose and stuff. So I wanted to know that even though our like materials list or whatever isn't due for like another month, do you think I should like just keep it ready and stuff before I start doing my project?
Yeah,
Or do I want to start?
it's always a good thing to be ahead of the game and to be prepared. So I think it's a good idea. I think it's a good idea if you start earlier.
Yeah, it's especially with this time crunch because we have a lot less time than we usually would for experiments. Because
You
now
just
we have
want to
like
make sure
2 months.
you want to make sure that you have like all your like materials together, like your procedures lined up as soon as possible, so you're able to. Because you said that your experiment might take a little bit of time, and since like Connor and Catherine were saying, we're on a bit of a crunch this year, so I think that's a good idea.
Okay, thank you.
No problem. And one piece of advice I have that I've kind of learned the hard way is set aside time like every weekend to just try, and even if it's not much, even if you're just like making a plan for your science fair project, set aside that time to work on it. Because I've left it to like Christmas break to actually start testing, and then you're just really, really stressing yourself out, which isn't really necessarily worth it. Yeah.
Yeah. It's
There's
really
something else. You can go, Catherine.
All right, yeah, cool. It's also really important to make a timeline of your science fair project so that you don't find yourself, the day before something's due, having to do all of your work in one day. So it's really important to space out your work so that it doesn't feel like it's as much, and so that you're more prepared.
Yeah, for sure. So something else I wanted to say was that even if you are like finished like with your background research or your introduction already, I would like continue keeping up to date with like current events that have to do with your project or with the topic of your project, because I know that from experience, judges will during question and answer time, when you're presenting your project, they'll be like, oh, I saw this on the news, or I saw this current event that has to do with your topic, and you want to be able to have a conversation with them and show that you are that you know the current events that are going on within like the realm of your project, and you want to be able to show that you're continuing to do research in addition to your actual experimentation. So I suggest like looking into current events of things that are occurring like within the realm of your project, and so you're always prepared for any questions or any discussions that the judges might have during your presentation.
Alrighty, Dylan. So no one's in group 5 because we just thought that it'd be better to have 4 groups. So now you can share your project if you would like.
Okay, so basically, I hit golf balls in different temperatures and then find the difference in distances.
Is that going to be a physics project?
Yeah, it's something about like density of air and like different things.
Yeah.
Yeah, that's more physical sciences.
Yeah, we don't have a physical science call though, so he's just in here.
Oh, okay.
Yeah, because no one joined. So, yeah, I actually saw a project quite like that at State, so it's definitely a really cool topic to look at. One thing you could do to maybe, this might be hard to do with maybe golf balls because they're just in their hard form, but like take the pressure of it. I'm not sure if that's really possible, or maybe look at some other factor additionally to really help take it to the next level.
Okay.
And yeah, so are you gonna be like hand swinging the golf balls to determine distance?
Wait, what did you say?
So your project is like the temperatures of golf balls?
The temperature of the air.
Oh, the temperature of the air. So that's a little because you can't really determine you can't really determine fully the temperature of the air every like for the day. You have good estimates. So it might be a little fast paced, like, okay, what temperature is it right now? Oh, it's okay, it's like 56 degrees. Let's try it. And then it's subject to change. So you always want to keep track of how hot or how cold it is.
Yeah.
And so okay, so you're gonna be like swinging. You're gonna be like swinging So are you gonna make a contraption to like shoot them, or are you just gonna swing?
I like use like one of those things that track the ball distance and it also tracks different things, and like I could like make sure that some of the other variables like swing speed are this exact same.
Okay, that's great. Yeah, that will
Okay,
actually.
yeah, that's good. It's
That's what
pretty
we
good.
wanted to clarify to make sure, just to eliminate any chance of like human error. So say you were to swing one like not as hard as the other, that would affect your results. So it's good that you're thinking ahead and like eliminating those kind of outliers in your project.
Yeah.
So does anyone have experimenting with their project?
I guess everybody's comfortable. All right, that's good. Good to know that you guys are all pretty confident in your projects.
All right, so how about some inspiring, and we can go show you guys some really cool science fair projects to get you guys inspired about science fair.
Yeah, this is basically just to show you like what's really possible, like what could you really do with science fair, and it basically just, yeah, like I said, it shows you what's possible and what people can actually accomplish and how really cool that is when they're driven by something, and we want you guys to be able to do the same. So yeah, I can start us off if you want.
Alrighty, so
yeah, so
yeah, sure.
Give me a moment. Let me think of one. Okay, so a friend of mine last year, what they did was they basically they had noticed how big of an issue deaths caused by asthma were because it happens and it helps. He basically created an app software that helps detect while exercising if you're about to have an asthma attack. So if any sudden drops in any key indicators that could lead to an asthma attack, it will pick those up for you and give you a warning. So I thought that was a really cool project because first of all, he put a lot of coding into it and was able to physically create this app, and it's going to help. It has the potential to help a lot of people, especially since this is such a big problem that a lot of people have to face.
Yeah, that's really impressive. I think Rotem should share her project because she has a really cool life science project that could probably inspire everyone here.
Thank you. So should I talk about my last year project, my 9th grade one?
Any is fine.
Yeah, they're all good.
So, thank you. 9th grade, so I'm a sophomore this year, and last year in 9th grade, I'm actually continuing this project this year, but I did a project with with a friend. I did a partner project, and what we did was we basically saw that, radiotherapy is like a common way to like combat cancer, right? And so it has a lot of negative side effects. And so basically what we wanted to do was we wanted to find an antioxidant in which we could utilize that to mitigate the negative side effects of radiotherapy. And so what we did was we took a model for like healthy cells that we then irradiated, and we were able to expose them to 4 different antioxidants and to see which antioxidant would help them regenerate and recuperate faster from the radiotherapy. And we're actually continuing the project this year, and we're going to continue to do our research and our continuation project. A lot of people do them, and it's able to advance your project more and more over the years. And so we're going to be focusing on, instead of like 4 different antioxidants this year, we're going to be focusing on the one that we found was most beneficial last year. And so we want to be able to, this has like a lot of real world applications, and that's why we really want to focus on that topic, because a lot of people are affected by cancer, of course, because it's an extremely prevalent disease.
Right, yes, that's like an example of a really, really cool project. So
Yeah.
does anyone have
Hit
any
up all the good
comments
points.
or like questions?
I think everybody gets the idea. It's a very good project for a lot of reasons, because it hits almost every single note of that like distinguishes an outstanding science fair project. It's, first of all, in the medical field, which is in and of itself very competitive and very intricate, and it's also very applicable because you know, cancer is still a very prevalent problem nowadays, and good execution. It's a branch off your last year's project, which I saw, which is very good. And a lot of times, if you have a good project and you know you want to continue with it, that always leads to like good results, because you already have a good base idea and you don't need to put too much. You don't need to exert too much thought on like, what am I gonna do? How am I gonna do it? And then you need to like start from scratch. So it's only going to get, I would say, like better from there. And there's not a lot of room for error.
All right, so before we go, I want everyone to say what they want, say what they need the most help in with science fair, so that we know how to better help you and personalize our workshops to help you guys more. All right, so who wants to go first?
Last year, I had lots of trouble with the materials and procedures, because as I went on with the experiment, I kept having to change it again and again, and adding stuff and removing stuff.
I very much related to that one, and you know, that's just part of the process. So again, the only way I really think you can prevent that is just trying to think through any potential errors beforehand. I definitely understand that, because it is very stressful having to retry multiple things to try and produce a good project. So
Yeah, and that's why it's really important to start early, so that you have time to errors.
Yeah, I completely agree. I've had to go through like a lot of different procedures to get to kind of where I am today with this project.
All right.
yeah, so that's pretty much the hour-long workshop. So feel free to go if you have you have homework and other things to do. So
Oh, that's right. Well, thank you all for coming. I hope you guys learned just a little bit more today, and I hope we could help you a little. If you have questions, feel free to stay back.
Hi.
Thank you.
Of course.
No problem. Thank you for coming.
Yeah, we loved having you.
Thanks for coming.
Wait, we had 4 people? Holy. Okay, I did not know that. I couldn't.
One of the kids who was talking about the soil, he sent me an image